Hello, ladies and gentlemen. I hope you're all doing well and you're ready for more of our Canadian Open paper. This time we are on question A3. And what have we got? Points 0, 0, and 3 root 7, 7 root 3 are the endpoints of a diameter of a circle that they are calling gamma. Determine the other x-intercept of gamma. Okay, well, we could maybe draw a little picture just to get a sort of an idea. So it passes through the origin, and then they're giving me two positive numbers, 3 root 7 and 7 root 3. So I'm going to say, 3 root 7. Root 7 is what? It's between 2 and 3. So multiply by 3, it's about 6-ish. And then 7 root 3 is about, I don't know, 11-ish, something like that. So we're looking at a circle whose diameter maybe looks like this. Okay. And so as I'm writing it out, I'm realizing, thanks to my picture, that this is not bad to work with. So hold on. First, there's a couple ways you could try and do this. You could try and figure out the diameter itself, right? Just use the Pythagorean theorem. As you go from 0 up to 3 root 7, 7 root 3. Do I have the order right? 3 root 7, 7 root 3. Okay, good. So 3 times root 7 would be 63. 7 root 3 squared would be 49 times 3, so that'd be 147. Add those up, and it'll be 210, so we're looking at a square root of 210 here. Not the nicest thing to work with. But, you know, if you want to go that way, you could try to set up an equation. You can figure out the midpoint here. It's the average of the coordinates. And you really could make a serious attempt to find the equation of the circle. Okay, and that would be perfectly fine. That's actually what I was intending to do because I didn't have an immediate plan. But as I drew the picture, and I'm going to draw it again here. I know I've got a point up here. And I sort of figured out my x point first, and then just went up from there, right? So you'll get a right angle triangle, right? If you just go over by 3 root 7 and up by 7 root 3, right? That's how our rectangular or Cartesian coordinate system works. Except this is a diameter, right? This is a diameter. So when I draw my semicircle, what do we know about right angles and semicircles? Well, if you are a point on a semicircle, and if I connect you up to the endpoints of the diameter, you're going to make a right angle. This is, I want to say this is called Thales' theorem, Thales. Somebody can correct me down below if that's wrong. But it's a very well-known circle result that if you've got a diameter and you're a point on a semicircle, connect up to the endpoints of the diameter, you'll make a right angle. And if you make a right angle with a diameter, you must be on the semicircle. You must be on the arc of the semicircle. So as I was drawing it, suddenly that clicked into my brain, and now I know where the x-coordinate is, because the x-coordinate is horizontally over from 0, 0, and we make a nice little right angle as we go up to 7 root 3. So we just need to go over by, what have we got here? 3 root 7. So 3 root 7, and don't go up. This is the point that you'll need. So what were they asking for specifically? Determine the other x-intercept. 3 root 7, 0. That's all we need. If you wanted to be fancy, you could say 3 root 7, because when people ask for an x-intercept, it's assumed that obviously the other value will be 0. But, you know, I never bothered to chance those things. I mean, how hard is it to write the brackets? Okay? But there we go. I mean, if you want to explore finding the equation of the circle on your own, you're more than welcome to, but I think a little bit of circle geometry can save us a fair bit of time. All right, so up next, we're going to take a look at question A4, and that's actually going to conclude the A part of the contest. After that, it'll be B1, which is worth just a little bit more. But first, A4, and I will see you for that next time.